All right, so in our last video, we talked about how to use grouping to factor something that only has 3 terms. And we talked about that the trick to that is they have to start by uncombining that middle term. If it's been a little while since you've watched that video, you might want to go back and watch at least part of that again or review your notes before you watch this video. In this video, basically all we're going to do is we're going to build on that idea, but play with that polynomial slightly, specifically for the purposes of varying signs, whether things are positive or negative. And we're going to talk about how the different sign impacts the way that you're going to do the problem. Okay, so that's really our goal for this video. Let's take a look at our learning objective real fast. And here we go. So only one learning objective, same as it was before. Factor a trinomial. Remember, trinomial just means it's a polynomial with 3 terms. Factor a trinomial using grouping. And from the last video, we came up with this procedure. Well, from 2 videos ago, we had our procedure for grouping. But then from the last video, we also talked about if there's only 3 terms that we're going to go through this process. And one of the things that I talked about is that right here, when you decide whether you are adding or subtracting, right? So step 3 is choose the factor pair that either adds or subtracts to equal the middle term. When you're adding or subtracting, we talked about this is the only time that you look at any signs. Prior to that, you just treat everything like it's always positive. Okay, so everything before that, treat everything as if it was positive. Okay, so you just ignore signs. This is the first time you look at any sign. Okay, and when you look at that sign, we talked about in the last video which sign it is that you're looking at and how you know whether you're adding or subtracting. Specifically, it's the sign on the constant at the end of the polynomial, the last sign. If that last sign is a plus, then you're adding. If that last sign is a minus, then you're subtracting, okay? But now I'm saying that that's the first time that you look at a sign. Once you decide what your middle factors are, there's really kind of like a step 3.5 here, or maybe you might call it step 4, okay? And that's where you decide what signs the 2 numbers are going to get when you split up the middle term. So I'm going to say pick signs for splitting the middle term. I'm running out of room, so I'm just going to put MT for middle term, okay? But I'm running out of room there. So pick signs for splitting the middle term. And really, that's what this video is going to focus on. We're really going to focus on how do you decide what sign. So everything before this tells me which numbers to pick. So when I'm picking the numbers, I'm functionally ignoring signs in that process. But eventually, I do have to deal with the fact that things have to add up correctly. All right, so with all of that said, let's get started by taking a look at this example here. So example number 1, let's say that I have an x squared minus a 13x plus a 42. Okay, x squared minus 13x plus 42. Right? We're still going to use this same procedure, this same process, but I don't have room to show both of them on the same screen. So hopefully you've got this written down in your notes from before and you can take a look at it. But the first thing that we said we're going to do is we're going to multiply the leading coefficient, which is the number in front of the x squared, times the constant, which is the number at the end. And we're going to ignore signs. We're just going to treat them all like they're positive. Well, in this case, they're all positive anyway, so it doesn't matter. But if anything was negative here, we would just ignore that. So I've got a ninja 1 times a 42. And of course, anything times 1 is just itself. So 1 times 42 is 42. So there's my first step. Second step, find all the factor pairs of 42. Again, just treating everything like it's positive. So I could have a positive 1 times a positive 42. I could have 2 times 21. I could have 3 times, what would it be? 14, I think. Maybe I should have done this in advance. 4 4 does not work, 5 doesn't work, and then 6 times 7, and then I think that would be it. Okay, so there we go. So there are our factor pairs. And again, remember, if you have trouble with factor pairs, that you can always Google that using Wolfram Alpha. Just type into Wolfram Alpha, what are the factor pairs of 42, and it should give you that list. Okay, so that takes care of step 2. Step 3, this is the first time we're going to look at a sign. We're going to pick the one factor pair that does this to equal this number. Now here, I'm just looking at the 13. I'm still ignoring the sign on the 13 for now. So the first time I look at the sign, the only sign I'm looking at is this plus. So I'm going to pick the one pair that adds up to 13. Well, there's only one pair that adds up to 13. It's this one. 6 plus 7 equals 13. Okay, so now this is our like step 3.5. I need to choose signs for the 6 and the 7. So I know that the 13 is going to split up to be a 6x and a 7x. And those are going to combine together through the process of adding. Okay, I know that. But when they add together, now I need to account for the fact that they have to add up to be a negative 13. So this is why I call this like step 3.5. I've already figured out that 6 and 7 are going to be the things that add up to be 13. Remember, the add, that's coming from the fact that this was a plus. These two signs right here, they're going to always match each other. Okay, but they need to add up to be negative 13. Well, the only way that could happen is if both of these were negative to start with. It must have been a negative 6 plus a negative 7. Because a positive 6 and a positive 7 would give me positive 13. And if one of these was positive and one of them was negative, I would either be getting a positive 1 or a negative 1, depending on which one was positive and which one was negative. So it has to be the case that they're both negative in order for them to add up to be 13. Okay? Now, as a big hint, this is pretty much universally true. This is, I think, universally true. I can't think of an exception. I'm pretty sure this is universal. If this is a plus sign here, it's got to be the case, assuming that we're working with real numbers, which we are. If this is a plus sign here, then these will have the same sign. They'll either both be positive or they'll both be negative, one or the other. In this case, they're going to both be negative. So that's a little hint. Maybe you should jot that in your notes, remind yourself in the future something. But anytime this is a plus sign, these are going to have the same sign, either both positive 6 or both negative positive 6 or 7, one or the other. Okay. Now, I can't forget that I've got a plus 42 and I've got this x squared out in the front. And so there I have my uncombining of the middle term. And again, I can always check this. Does negative 6 plus negative 7, if I were to combine those like terms, would I end up with the original problem? Yes, I would. All right, so now that I've combined like terms, now I pick it up with my factoring. I'm going to treat this as two separate problems with a plus sign in the middle. And I'm going to factor each one using the greatest common factor. So for my first one, they have an x in common. And then if I were to undistribute an x, the thing in the parentheses, well, it would have to be an x times another x to give me an x squared. So this must be x. And then to get a negative 6x, it must have been x times a negative 6 to give me a negative 6x. I know that this has to be an x minus 6 here. So what I would do is I would just divide positive 42 divided by negative 6. That's going to equal negative 7. And I can double check, does negative 7 times positive x equal negative 7x? Yes, it does. So that takes care of my second step. I've done greatest common factor from each of those. And I've used my little trick or shortcut on that process. Final step, there's my super greatest common factor. So I'm going to write that down and then write down the stuff that would have been distributed to when I was multiplying. And so there's my answer. Okay, so that's the first example of how to deal with signs. The first time I look at the sign is to decide, am I adding or subtracting? So I decided I was adding. That also gave me the hint that these were going to have the same signs. They're both going to be positive or both be negative. And then I looked at this to decide that they were going to both be negative. Okay, so that's the 2 times I look at the sign. Now, I want to look at 2 different problems. I'm going to show you 2 problems at once. I'm going to ask you to pause the video and try both of these. And these 2 problems I've picked specifically for the purpose of emphasizing how important it is to ignore signs until you get to the right spot of the problem. Okay, so here we go. 2x squared minus 5x plus 3. There's my first one. And then my second one, 2x squared plus 5x minus 3. Okay, so very similar problems, the exact same numbers. I've just fiddled with the signs. Now, what I would like you to do is pause the video right now and try both of those. If you're not careful with the signs, you're going to end up with answers that seem like they should make sense, but when you multiply them out, you're not going to get the right response. Okay, so try these carefully. Once you got them done, then resume the video and let's take a look at them. All right, so hopefully you've tried these. I'm going to do some of this work is going to be the same for both of them. So initially, I'm going to start off and just do both of them at the same time. So I know I'm supposed to multiply my leading coefficient times my constant. I've suggested that when you multiply those together, you ignore the signs. So in both cases, I'm just going to do a 2 times a 3. I'm going to ignore the fact that this is negative. 2 times 3 is equal to 6. So there's where I'm going to start. Then I find my factor pairs of 6. Well, that's 1 times 6 and 2 times 3. Again, just treating everything like it's positive. Okay. And now I'm on step 3, and this is where the 2 problems become different. In the first problem, I'm going to pick the pair that do this to equal this number. Okay. The pair that do this to equal this number, and I'm doing that ignoring the signs. Ignoring the signs. So which 2 add up to equal 5 if I ignore signs? Well, it's 2 and it's 3. Those are the 2 that add up to equal 5 if I ignore signs. So I'm going to take that 5 and I'm going to split it into a 2x plus a 3x. Okay, again, that plus comes from the fact that this is a plus. Okay, now I'm going to look at the signs. I need them to add up to be a negative 5. We just said a minute ago that there's this sort of little helpful hint that if they're both going to add up, that they must have the same sign. If they're going to add up to be a negative 5, well, then they both have to be negative. So I get a negative 2x plus a negative 3x plus 3 at the end and a 2x squared at the beginning. Okay, now, if you were not looking carefully at the signs, you might have made a mistake there. And here's the common mistake that people make. They look at a 1 and a 6 and they say, well, if I did a positive 1 plus a negative 6, I would have ended up with negative 5x. But the problem is that it's not going to factor correctly. If you try to multiply that back out, if you check your work, you're going to find that you get a different answer. This is not the answer that you get. In fact, we're going to find that the answer you get is something that looks a little more like this. Okay, so let's talk about why that is. On this problem, and I know this problem isn't done yet. We'll finish it in a minute. But my focus right now is on why it's so important to ignore the signs. So I want to stay focused on signs before we worry about finishing the grouping. So in this problem, I'm still ignoring all the signs, but now I'm going to treat this like it's a positive 5. And I'm going to ask myself, which 2 numbers now subtract to equal positive 5? Which 2 numbers subtract to equal positive 5? And so that answer is going to be a 6 and a 1 if I ignore signs. Now, if I don't ignore signs, you might say something like, well, 2 minus a negative 3 equals positive 5. And that's true. 2 minus negative 3 does equal positive 5. But it's not going to factor correctly if that's the way you split the 5 up. It's not going to factor correctly. So it's really important that you ignore the signs at this step. The only sign I'm looking at is the fact that it's a minus. That's the only sign I'm looking at. Okay, so now I've decided it's 1 and 6. Now this is the second time that I look at my sign. when I split this up, I've got to use a 1 and a 6. I've got to subtract them, and I have to subtract them in such a way that I end up with a positive 5. Well, if I do 1 minus 6, I get negative 5. If I do 6 minus 1, I get positive 5. So it must be the case that I have a 6 minus 1 because it has to equal positive 5. And you could write that 1 as a ninja if you wanted to, and that would be fine. Drop down the other pieces. I've got this negative 3. I've got this 2x squared. This is a positive 6, so I'll put in that plus sign, and there we go. Okay, so again, notice the numbers are almost exactly the same in these two problems. I've got a 2, I've got a 5, I've got a 3. Just by switching the signs, it changes which factor pair I'm going to use. And if you ignore this sign in the middle, you'll end up with the correct factor, or you'll end up with the correct two numbers if you ignore that sign to start with. Then once you've picked the two numbers, then you look at that sign to decide whether they're going to be positive or negative at that point. Okay, if you don't ignore that sign at first, then it's easy to convince yourself that the wrong numbers go in whichever slot. Okay, and I will say the most common mistake that people make is not on the second one. The most common mistake people make is on the first one, where they try to add together a negative or a 1 and a negative 6, and that just simply won't work. And if you don't believe me, try to do the problem. When you're all done, multiply it back out and see if this is what you get, and you're going to find that's not what you get. Okay, so it just doesn't work. You can trust me, you can try it, that's up to you. All right, now let's go ahead and finish these just for the sake of completeness, but the point I wanted to make we have made, and that was how important it was to ignore the signs until you get to the right point in the problem. All right, so finishing this up, I'm going to split this into my two groups. In my two groups here, this group, they have a 2 and an x in common, so I can take that out. What's going to be left behind? Well, my numbers are just going to go down to 1, right? Because 2 times 1 gives me 2. So my numbers are going to go down to 1s, but I need to have an x in the first spot. So I've got x times an x to give me an x squared. So I'm going to have a 1x or a ninja x minus sign right here. And then this has to have a 1. Now this one cannot be a ninja, right? If that one was a ninja, then I wouldn't know what I was multiplying by. That one's not allowed to be a ninja. I have to be able to see that one. There's my first answer. That means this one also has to have an x minus 1. A 3 divided by negative 1, that's equal to negative 3. So that must be the number that got distributed. And I can always check that. Negative 3 times x does equal negative 3x. So my final answer is my super GCF times the other stuff. And there's my answer from example number 2. Okay. For example number 3, same idea. I'm going to take this thing, I'm going to treat this as plus a negative, and then do that thing, and look for their greatest common factors. So here I also am going to have a greatest common factor of a 2x, but this time I'm going to have an x and then a plus 3 in the parentheses. And I can double check that. If I distribute 2x, that is what I'm going to get. So this also has to have an x plus 3. A negative 3 divided by a positive 3 is equal to negative 1. So that must be what got distributed. And if I check it, yes, it does work. I get the right answer. So my super GCF times the other stuff is my final answer. Okay, so 3 examples there where we're playing with the signs and talking about when do you look at it and when do you don't, and when do you decide if it's positive or when do you decide if it's negative. Hopefully you found that helpful. In the homework, you're going to have plenty more problems where it's working with signs and trying to decide are they positive or negative. As always, let me know if you've got questions, contact me, and I'll try to help. Thanks for watching this video. Have a good one.